Hello, this video is to talk about some organic chemistry, the reactions of carboxylic acid derivatives. It's a past paper question from OCR F324 in Jan 2010. So the examiners have given a couple of named chemicals, and they are chemicals that actually quite a lot of people have heard of this time. So there is aspirin and there's paracetamol. And looking at them, you can see there's quite a lot of chemistry here. There is certainly a benzene ring in the paracetamol, and with the OH there making it a phenol, and then we've got an amide link here. Aspirin, we've got the carboxylic acid group of the benzene, and then we have an ester link. And it tells you that both aspirin and paracetamol can be paired using ethanoic anhydride, and they give the formula of that there. And they give some examples of the reactions. Now what I've done down below is I've drawn ethanoic anhydride out. And again, we've got a carboxylic acid derivative, so it's got a delta positive carbon, and what happens with all of the reactions is a nucleophile attacks in here, and you break the bond, and what you're going to get to is this situation here, where you've got an addition step first, and then a lone pair on the oxide ion that's forming there is then going to come back down to the carbon, which is still delta positive, and we're going to break the bond. So basically what happens each time is that you're breaking this off. That would of course initially give us H3C double bond to the O with a nucleophile there, and you would have ethanoate ion, which would then be protonated, and that will give you the ethanoic acid that you're always going to get as your byproduct. And if you look, there's a nucleophile, the alcohol, a nucleophile, and a nucleophile, and each time if you see you're getting the H3CCO, well, they've written it CH3CO, and then turning it round, they've tried to hide it a little bit, but the atom that is possessing the lone pair that can allow it to function as a nucleophile, you're going to switch these molecules round and you're going to lose a proton from each of them. Now I had the nucleophile there. If I had it as NUH, then it would be plus for a moment until we lose the proton, which will get picked up by the ethanoate. So therefore, let's look back up here. We form an ester link when we do our reaction here. If there's an oxygen, we form an amide link if it's a nitrogen. And if we look, there's the amide, there is the ester. So the new bond that has been formed is between this oxygen and this carbon. So simply, this has come from the ethanoic anhydride, and all of this has come from the nucleophile. So we can put everything else that hasn't changed in place, and then as for all of these, we can add the hydrogen. So that is your molecule to start. Over the page, ethanoic anhydride can react with 4-aminophenol to produce paracetamol. Write an equation showing structural formula for this formation of paracetamol. Again, don't panic, you can take the structural formula from ethanoic anhydride that was given over the page, and phenol, which you all know is C6H5OH, and then the 4-amino is H2N, and then that turns it into a 4 because you've removed one hydrogen. You can do either. Either of these ways were accepted. I'm going to do this because it's certainly got some more information given for us, and well, hang on, paracetamol's already given to us, so fine, I will take that. The other thing you could do is, even if you were panicking about the 4-aminophenol, just like we did for aspirin, you are going to break the bond from the carbon here, and so simply replace it with a hydrogen. So we have the H2N, the benzene ring, and the OH. So going back here to draw our paracetamol, which we're just copying from over the page, And as with every single one of them, we are getting CH3COOH, which you can compare. You're always getting the ethanoic acid as your byproduct. They gave 1 mark for the reactants and 1 mark for the products. Next question down. An impurity with the molecular formula C10H11NO3 is also formed. So the first thing that I did is I looked at my paracetamol and I worked out the formula of paracetamol to see how far away from this it is. And I need 2 carbons, I need 2 more hydrogens and 1 more oxygen. And this all came from reacting this chemical with ethanoic anhydride. And what we've just seen about ethanoic anhydride is it reacts with nucleophiles. And this oxygen on the paracetamol, this phenolic oxygen, can behave as a nucleophile. And so therefore, we also know that ethanoic anhydride is good at adding 2 carbons. So that is simply what you're going to get. Again, you're going to have everything else about paracetamol stay the same, and then the oxygen will now make another ester link. So it's that bit about knowing that ethanoic anhydride reacts with nucleophiles. There's not going to be anything happening here. The amide is not a nucleophilic group, but this is here, the OH with its lone pair. Even though it's not as strong a nucleophile because it's shared in with the delocalized electron ring system, it's still capable of being a nucleophile. Right. Explain why it is necessary for pharmaceutical companies to ensure that drugs and medicines are pure. This is the kind of question that Year 13s panic about. Simply put, what might happen if there were some other things in paracetamol? Well, side effects. It could be anything there. You could put in brackets, or you could put harmful side effects. Other things that you could just put are harmful or hazardous. Because of course you're ingesting this, and you really don't want to be ingesting chemicals that you don't know what they are. Right, so the names of the functional groups in aspirin and paracetamol, I'm going to write them here. The aspirin, this is the carboxylic acid, and as we discussed earlier, there's an ester. Note that it said groups. The most common mistake here is that people only put one of them. If you get one of these molecules and you're asked to name the functional groups, make sure that you get all of the functional groups, not just one. We've got our amide, and then the one that most people will drop the mark because they will see this and it will go alcohol, but because it's the OH bonded directly to the benzene ring, it is a phenol. Thank you.